This production is sponsored and funded by Montana Fish, Wildlife and Parks, Gallagher Power Fence Incorporated, and USDA APHIS Wildlife Services. Protecting bee yards from intruding bears is the purpose of this presentation. Electricity is a proven retardant when used properly. The design of this bear-proof bee yard is one of innumerable. But if the directives here are followed and the equipment maintained properly, bear problems in bee yards will be a thing of the past for you. The first step is to lay the welded number 4 gauge wire cattle panels out on the ground in a circle or some other figure that works for you.
The reason why I put them in a circular configuration is so that I get less pressure bearing on each corner. On a rectangular one, you get more pressure on the corners of the fences. We usually pull our truck in the center of the yard to disperse all the supers and equipment off. Then it's easier for us to work, I think, in a round yard than a rectangular one. And the other thing is with your hot wires, they seem to stay away from the fence and not be grounded as much in a round fashion than they do in a rectangular one.
Next, drive 6.5 or 7 foot tall steel fence posts into the ground down to the flange. Make sure the knobbed side of the fence post faces to the outside of the enclosure.
Point the knobs out, facing to the outside, because the insulator that'll clamp onto the top post clamps over the knob, so it has to be facing out in order to work.
Fence posts should be positioned at the center and ends of each panel. A little overlap is okay. Cattle panels should be connected to steel posts with galvanized clips or galvanized double wire.
We got a regular steel fence post clip here for these that come with these steel posts on our corners right here. We're connecting each one panel to the other panel with this galvanized clip by taking in a screwdriver here, just putting it on there, wrapping it around, and we've just tied our panel right to the steel post.
If galvanized tie wires are used, the ties need to be tied on the inside.
And we're going to tie the panels in 3 locations. The idea is to get the panel so it's good and strong onto the steel post. We're doing all the tying from the inside. We want the tails on the inside where they're going to be away from the electrical wires. A 2 foot length of wire doubled in half, 12 inches long, would make a plenty adequate tie wire. The only thing you really need working with this stuff is a screwdriver, a 6-inch Krensel wrench, power fence pliers, or a pair of lineman dikes.
This particular setup does have a mistake you should not make. Too short of posts were used, 6-footers. Problems can occur when the posts are shorter than 6.5 feet, and 7-footers are even better.
These posts need to be about 8 to 12 inches above the welded panel. Because see, this is going to be our top wire right here. And that's marginal right there at best. That way then anything that lands on there, I mean like birds, or if you get some sticks that are blowing over, that type of thing, and hit this, they're not going to drive it down and force it on top of here.
One cattle panel with a fence post at each end is used for the gate. On the gate, doubled galvanized wire is wrapped 2 or 3 times around the panel and fence post at 3 different points to make a good gate hinge.
It's important that we use this galvanized panel as our ground system attached to our ground rod, so when the bear decides to climb up the galvanized panel, he's very well grounded. When he comes in contact with the top poly wire up here, the turbo wire, then he'll be grounded. That'll take the shock right back to the...
The next step is to install the offsets, numbers G659P, and insulators, numbers G681L, on the fence posts and welded cattle panels. All the plastic on these electrical items need to be UV stabilized.
This insulator is guaranteed for 10 years not to break down into sunlight, and that's very important because if an insulator gets brittle and a bear comes up and takes a swing at it and it shatters it, and that'll happen on about the second year of a non-treated insulator, then you will end up with a broken insulator and probably a penetration into your hive site.
This plastic insulator with pin is attached to the end of the offset.
Here's the way it's done, okay? Follow me now, guys, because this is important. First of all, this is a flash plate, okay? That's what we call the flash plate. We take our insulator, put it in our left hand, take and grab a hold of the offset wire bracket by the upper end, by what we call the feet, okay? Grab it by the feet, and at a right angle to the insulator, force it on right behind the insulator flash plate into the groove of the insulator. The insulator will snap and it will stay in place, okay? Once it's in place, grab the feet and pull them apart about 6 inches, okay? Then rest the insulator on your kneecap and force the insulator to be parallel then with the wire, and for the insulator grooves to fall in place with the wire. Rotate the whole bracket then counterclockwise 1/4 of a turn, okay? To lock the insulator into place with the wire, then pull the legs apart about 12 to 14 inches to lock the wire in place right behind the insulator. Once you've got the bracket installed, the way to tell if it's correct is to hold it up facing you. You've got a right leg and a right foot. You've got a left leg and a left foot. If you have it wrong and you haven't crossed the wire, first of all, there will be a gap in the 8-gauge spring steel wire right here. Okay, right underneath the insulator. And your right leg will have a left foot. Your left leg will have a right foot. At that point, you grab the feet of the offset and you rotate it 180 degrees. And you bring it back in so that now we're touching right below the insulator, and right leg, right foot, left leg, left foot. Very important that you learn to put those on right, because I'll guarantee you, if you don't have that insulator locked on, something's going to come out of here, and you're going to have this insulator pop out, and there goes the integrity of your fence.
An offset is placed at the end of a cattle panel close to the post.
Our welded panel is sticking out just a little bit, so that's the panel that we want to be able to put our offset on. We definitely got to have it at least nose high, but at any time we can entice the bear to put his paws on to our galvanized panels here, then touch the hot wire, he's going to get 5 times harder shock than if he's standing on the soil and just reaches up and touches the poly.
The brackets of the offset are going on the 3rd and 5th wires of the panel. The feet of the offset brackets are twisted around these wires using a screwdriver to bend and stress them a little into secure positions.
Yep, and literally hold it in place and bend the foot just enough so that the foot's sticking out. It's wrapped around our horizontal wires here now. It's in place. It's locked on. So if an animal tries to knock it off, she's going to stay in place. Each one on our corner and 16 feet apart, basically, except on the gate where we went ahead and put one in the middle.
Once offsets are installed around the perimeter, we're ready to install insulators on top of the fence posts.
It's got a notch in the back of the insulator, okay? And that notch fits over the knob of the steel post. That's why we have to have the steel post facing out away from the center of the yard. So we take the insulator, we set it on the steel post, okay, over the knob, and we push on it real hard, and it snaps into place. Snapped in here now, and secured on the post so it won't come off. The pin, it doesn't matter whether the pin is facing up or down. It's important, though, that when we install the pin, that we install the pin from the top down, not from the bottom up.
Again, your posts need to be 8 to 10 inches taller than these to keep the top turbo wire from accidentally hitting the panels acting as ground below. Turbo tape, carrying a positive charge, is placed in the offsets.
Turbo tape up to our offset, we fold it over, we put it in place, and then we lock the pin from the top down, push it down with our finger, and our turbo tape then is in place, folded over. It doesn't hurt to fold the tape over so that it comes in, fits the pin lock insulator. Animals are colorblind, and with this product here, it's white. Notice there's nothing white apart from the tape. There'll be white tape and white polywire, so that when the bear comes up, they'll see this white streak. And the idea is that when they see the white streak, then they literally stick their nose on it, because it's something that they're not really acquainted with out in their world. I think without a doubt that we can train the bears to realize that these yards are protected. When they see this white tape and the white wire, they will learn to equate that with an electrical shock, and they'll leave it alone.
Then turbo wire, also positive, is placed in the fence post insulators.
We've already got our insulator installed on the post. We're taking up turbo wire, we're running around here. I take and drop the pin in place, push the pin in just like we do on the offset bracket, and then we come on around. It's 9 strands of mixed metal. It's 40 times more conductive than any 6-strand polywire that's out there on the market.
All the metal on this electrical setup must be galvanized steel. If a plastic insulator pin lock breaks off, a galvanized nail can be used to hold the turbo wire or tape in place. Bend the nail below the insulator to keep it in place. A loop is tied in the turbo tape end at the gate start-finish. The turbo tape is product number G623X. The UV-stabilized plastic handle with spring in handle then hooks to the loop, completing the electrical connection.
That we've made, we bring it over, we hook it into our knot that we made, our loop on our knot, and there our gate handle is. And
another handle is tied to the turbo wire at the gate. The turbo wire is product number G620X. The handle is hooked to a loop tied at the end of the turbo wire. Caution should be used so the metal handle hook is back far enough from the fence post so it will not accidentally touch and ground out.
Our loop is done, then we can reach out. We've got the tension of the spring in the handle itself that holds the wire tight then all the way around the enclosure.
And do these, I prefer to set them back in the fence like this.
The gate is opened by breaking the positive connections and grounding out the system. This disconnect shuts down the power, but for safety, you may also want to shut off the energizer. Installing ground rods to complete the cattle panel ground system is the next logical step. In this demonstration, it was actually completed a step or two earlier.
Okay, we got ground rods here. We're going to position the ground rods right up here at the front, just as close as we can drive them to the welded panel. In fact, what we'll do is we'll pull the welded panel back just a little bit, and that way if you're mowing grass or you got your forklift coming in and around here, you're not going to be running over them. So you want them real close to the panel. The other thing that's very important is we're going to position these a minimum of 10 feet apart. So what I like to do is I like to just pace off 3 good long paces, because I take about a 3.5 foot step, and it's more important that they be positioned farther apart than too close together. We've got to have them at least 10 feet apart. It's great if we can drive this in the ground 6 feet down, because then we're in permanent soil moisture and it makes the energizer work a lot better. But in the case of rocky ground or hard ground where we can't get the rods in the ground, if you can't drive it the full 6 feet, drive it as deep as you can, take a hacksaw and cut it off about 6 inches above the ground. Take that remaining rod, move over here 10 feet away from that, drive it in the ground, okay? Then get another galvanized ground clamp.
You're wanting so many square inches of contact with the moist soil, hopefully somewhere down
That's what we're hoping for. Not hoping, that's what we need. These energizers, these Gallagher energizers, if they don't have adequate ground rods, grounding in the soil, okay, they will literally put energy into the ground rods themselves, okay? And so what happens, and I've seen this happen, when we get done here, we get the energizer hooked up, we're gonna test this ground field. We need to have 200 or less volts in our ground system. If we have more than 200 volts come in our ground system here, then we need to add another ground rod, or 2 maybe, okay? When we bring that voltage in the ground system down, you'll see the voltage in the fence come up. I've literally witnessed where I had 2 ground rods driven and had 1,800 volts on these ground rods. Grabbed a hold of the ground rods and got shocked. I drove 2 more ground rods in that fence and brought the voltage on our hot wire from 4,200 volts up to 7,200 volts. I did nothing to the Energizer. There's no adjusting it or anything. All I did was adjust the ground rods, the number. By adding ground rods, I brought the voltage up. And I'm not an electrical engineer. I can't tell you why that is. But these Energizers will be very effective if you've got adequate ground rods. The path that we're going to literally make that is foolproof is when the bear touches the hot wire and the galvanized panel at the same time. Then the electricity flows out of the hot wire, through the animal, into the galvanized panel, back to the Energizer that's connected to the galvanized panel, and inside, pow.
Soil moisture is not as important as the amount of voltage in the ground and the hot wire. You want most of it in the hot wire and very little in the ground.
Absolutely, you want none. Absolutely zero in the ground system is ideal. Adequate is 200 volts or less, okay? And the better the ground field is, the more energy you'll have out here to shock the animal. You'll generally find that you'll have to put 3 ground rods in 10 feet apart in order to get the voltage in the ground rods to under 200 volts. That's the rule of thumb.
Basically, you're better off putting 3 in the beginning.
You know, just to be on the safe side, 3 is not a bad idea. Okay, we've got our ground rods driven now. We need the double insulated cable right there, if you would, please, Claire. Thank you. Okay, this is double insulated wire. We're going to use this for all of our electrical connections. This insulation is rated to take 20,000 volts. You cannot use Romex or any kind of copper product when you're doing this, okay? It's very important that we don't use copper, because copper and galvanized zinc, which is galvanized, okay, galvanization, are 2 antagonistic metals. And if we connect copper to this zinc, then it'll corrode real fast from dew in the morning or rain. It'll corrode real fast and we'll lose our connection. Hence, the bear comes up, touches the fence. We don't have a ground system anymore. The bear's able to access the compound with no problem.
Product number G6352HD galvanized ground rod clamp is used to secure the stripped, doubled-over galvanized wire.
You might need to take a hammer and just set it on the rod here just a little bit. Widen that just a little bit if you kind of beveled the top of this post when you're putting it in.
By stripping 4 inches of insulation off of the wire a few feet back from the end, it can be doubled over to give more surface area contact at the clamp and to maintain an unbroken continuous path.
If you talk to an electrician, they'll tell you that anytime you cut a wire and put a splice in it, you always run the risk of having a poor connection. And it only takes a couple of minutes, you know, to peel it off like I did here with my pocket knife.
The ground rods are now connected to each other using product number G609 double insulated galvanized wire.
There again, I just double it up, okay? I double it up. Take my pliers and squish it together. See, now we got a continuous wire all the way from the welded panel right back to our Energizer. I like to leave these ground rod clamps and this wire up kind of high, and especially in this case here, because I know some of you guys come in here and do some mowing, and that way you can see it. You can get the lawnmower underneath it, weed eater.
Next, the continuous galvanized wire is connected from the final ground rod to the welded panels using product number G603L joint clamp.
See, I've got it doubled here so it won't come loose, and I've also given myself some slack right here so if this panel gets pushed one way or the other, that connection doesn't break. Very important that this connection right here never breaks. That's one reason why we're doing everything from the inside on this system here. Everything is built from the inside. The tie wires are inside, the ground wires are inside, the Energizer's inside, everything's done in here. That way then there's nothing out on the outside that a bear can get his teeth on or his paw on and pull loose.
The opposite end of this wire is available to connect to the B75 charger to complete the ground. Now you're ready to set up the business end of this exclosure. Your panels are attached. The offsets, insulators, turbo tape, and turbo wire are in place. The gate is established. The 6-foot ground rods are 10 feet apart and driven in. Now, these are the elements which produce the electric shock.
Our B75 Energizer. We've got our 12-volt deep cycle battery. And we got our 5.5 watt solar panel here to keep our 12-volt battery recharged.
Normally, for security purposes and to keep these items out of the weather, they'd be placed inside an empty honeybee box called a super. The solar panel could be nailed through the grommet holes to a board on the top of the super, angled 60 degrees to the sun.
So we take our super, we put it somewhere close to our ground rods. It's important that we have it in a position where it's not shaded by steel posts, trees, tall grass.
The deep cycle battery goes inside, on the wood, to protect it from cold and from sitting on the ground. The B75 Energizer box is UV stabilized plastic. Black and red battery connectors coming out of a white sheathed wire from the bottom of the box will be attached to the solar panel and then to the battery. Green and red alligator clips are attached to the negative and positive posts, also on the bottom of the Energizer. These will be clipped to the ground and hot turbo tape and turbo wire of the exclosure. Normally, the B75 Energizer would be protected inside the super also, but it is possible to hang it on a post, and for demonstration purposes, and to see where all the wires fit, that's what we're going to do this time. In order to connect the solar panel to the Energizer, you use the black and red leads from the panel.
These will connect to our red and black alligator clamps for our battery. The way to do that, take the red terminal and the red clamp, and inside the battery clamp itself is a spade fork in there, a male spade fork. We insert the red terminal on there. We take a flat screwdriver and we gently push the red terminal into the spade fork in our clamp, and then just clamp accordingly the wire right on to from our solar panel so that it won't become disengaged. Do the same with the black. Make sure that you take the black end of your solar panel and connect it to the black lead. There again, using our flat screwdriver, we gently push the spade fork into place on our solar panel. Now our solar panel now is connected to our Energizer. One thing you want to bear in mind, when you disconnect the Energizer leads from the battery, this solar panel will still power your Energizer. So if you want to come over here and just literally disconnect the battery, you're not going to shut the fence off. So if at that point you were to reach out and grab the wire, you would be shocked, because the solar panel has the ability to literally put enough energy into this B75 on a bright sunny day like this to power it. And attaching it, the battery will probably last without a charge for 6 weeks.
Now you're going to connect the turbo tape and turbo wire together so they will be the positive hot side of the system. Using approximately 6 feet of double insulated galvanized G609 wire, you will strip off 3 to 4 inches of insulation from both ends and 4 inches from the middle. One end of the galvanized wire is wrapped tightly around the turbo wire. Then the wire is pushed through the alternating squares of the welded panel, and the opposite end wrapped tightly around the turbo tape.
There again, if you hear any popping when you turn the Energizer on at this point, then we need to go and take a joint clamp and clamp that connection so that we have a good solid connection.
The bared center of the wire is bent double, and wrapped around a wire on the cattle panel to give it some stability. Then the red clamp on the wire from the Energizer is hooked to it.
Facing it on the inside so that we minimize the risk of something being able to reach out there and knock our connection off.
Now all parts are in place for the positive side. Now you can check the clamps on the ground rods holding the continuous cable connecting them. The clamps have to be tight to prevent any arcing. The stripped end of the wire is placed through an opening in the super and bent double. The green alligator clamp from the green terminal on the Energizer is the ground terminal and is connected to the ground wire inside the super. Now all parts are in place for the ground side.
What we've got now is our hot wire is connected and our red clamp connected to our insulated cable. Our green connection is our ground terminal, which in turn is connected to our ground rods, which in turn is connected to our welded wire panel. We have our black connection right here on our battery. We have our red connection right here, which is connected to our red terminal, and we have what's commonly called now fire in the hole.
And whatever is inside the compound is now safe from a curious passerby bear. Use a voltmeter to check the power of the system.
We lay it first on our ground grid, on our welded panel, and we just touch our turbo tape right here, and we've got anywhere between 67 and 7,300 volts is what it's pulsing at. On our top wire up here, we should have the same, 6,700 volts. Now, that's 6,700 volts is what a bear's going to receive if he comes up and he sticks his paw on this welded panel and touches that turbo wire or turbo tape while he's got his paw sitting on the welded panel.
But what if the bear just stands on the grass and touches the turbo tape with its nose?
Important that we take a reading like that. What we need to do is we take our probe and we don't stick this probe in the dirt. You don't stick it in the dirt like that. How many bears have a probe like that on their foot going down into soil moisture? Okay? What we do is we just lay it right on the grass, right on the top of the soil, and we reach right up here and we touch our turbo tape. He's receiving a shock here of about 58 to 6,200 volts. We have a better shock when we touch the welded panel and the turbo wire or the turbo tape versus touching the ground, the soil, and touching the turbo wire or the turbo tape. But anything over 4,000 volts is going to give the bear an adequate shock. But what we've done in this demonstration here is we've literally built a yard that has a ground system built right into it, meaning this welded wire panel connected to our ground rods is our main ground system. It's not our backup. The soil they're standing on is the backup system, okay? The soil and the moisture in the soil is the backup. The main primary ground is when the bear tries to crawl over this thing and he's touching the welded wire panel and the turbo wire or the turbo tape at the same time that he's in contact with the panel.